So we're going to go over this worksheet that I gave you, and I told you before it's a little bit weird. It's a little bit different. But let's see what we can do here. Um, I'm looking at the worksheet. It's page 49 at the bottom. All right, and we're going to do number 4. We talked about number 3 the other day. I recorded it. Okay, it's online, so you can always look at it. But I'm going to do number 4 because this is going to take a few times, probably more than a few times, to figure out what I'm asking here. Let's listen, please. So these are different. I'm not even going to say that they're really difficult. Okay, I don't think they're that hard because what you're going to see is there's really not a whole lot of stuff. Whoops, wrong tool here. Let's try this. There's not a lot of work that you have to do for this. It's really not. So I'm redrawing this picture for you. This is number 4 on the worksheet. Yeah. A. I told you which ones you had to do. Yeah. All right, here's what it says. I'm just doing number 4 right now. I can't do them all at once, okay? I'm just doing number 4 right now. Okay? I told you before what we were supposed to do. All right, here's what they tell you. This is what's given. And it says D is the midpoint. I'll just shorten that, put MP for midpoint of line segment AC. All right, so this is the stuff that they tell you about this picture right here. And they ask you to prove, and I'll just write that right here, that the triangles are congruent. So which triangles? Triangle ABD. And you want to show that that is congruent to triangle CBD. Alright, everything is written in white right here, so I'm going to change colors. We'll go to red so it stands out a little bit. And this is basically what you're going to have to do. That was you? Alright. So here, what do we do? Okay. Now, some of these say write a 2-column proof. Some of these say write a flow proof. Some say write a paragraph proof. I hope you're listening, all right? Because I already got this question once today, and we've kind of talked about this already. It says different ways to write the proofs. It says write a flow proof, write a 2-column proof, and write a paragraph proof, depending on the proof. I'm not going to ask you to do any of those things. So when it says write a flow proof, that doesn't mean anything right now, okay? I just want you to do what I'm showing you right here, okay? Remember, we're not doing, these aren't the proofs that I would do maybe in the honors class, okay? These are a modified proof. These are an easier way to do a proof, okay? I'm not going to have you do every little step. I'm just having you do kind of like an outline. You know how you do the whole paper? It's not like writing a whole research paper. It's just kind of doing like the outline. And that's what I'm doing right here. It's kind of like an outline of a proof. It's all it is. So what we're going to do is we're going to first of all mark the stuff on our paper that's given here. So AB is equal to CB. So here's our picture. I drew it out. And so we just mark it. How do I mark that AB is equal to CB? Put a little what? Little line. Put a little tick mark, right? That's what they call them, little tick marks. All right? So we put a little mark here, little mark here. That is part of your answer. It's not your whole answer, but it's part of getting the answer right. Everybody understand that? So when I ask you to do one of these proofs, this is part of what I want to see in order to get this problem right. Now, really, was that difficult at all? Not at all, okay? They told you that those 2 segments were equal, so I just put a tick mark on both of those segments. Look what else they tell you. They say D, point D, is the midpoint of AC. Well, let's come up here and look what they're talking about. Here's point D, this point right there. It says it's the midpoint of AC. Now we have to think a little bit more than we did on this one right here. We have to think a little bit about what that means. If this is the midpoint of this whole thing right here, what does that tell you about maybe the length of a line segment or something? Okay, they're equal on both sides. So tell me what are equal then. What line segments? AD and DC. That's right. So if this has one tick mark here, what am I going to do up here? I'm going to put 2 tick marks. And that's all they tell you, isn't it? That's all the given. Okay, that's the only thing they tell you. But there's one other thing that we could probably figure out. What are we trying to do, by the way? We're trying to prove that triangle ABD, this triangle right here, everybody see that triangle? And this triangle right here, CBD, CBD. So this triangle and this triangle right here, I'll just kind of shade it in. All right, you see that triangle? And you see this triangle? We're trying to show, if you want to, if you're trying to show that these two triangles right here are congruent to each other. So what do we know? We know that this side is equal to this side. We know this side is equal to this side. Remember, we had 2 ways to prove triangles congruent. Side, 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 or side, angle, side, right? Okay, so is there another way to get that third side? By the way, what is the third side? Here's one side, here's the second side. What's the other side? DB. Is there any way, excuse me, that DB on this triangle is equal to DB on this triangle? Because it's the same, that's right. Yeah, it is equal because this is the same on this triangle as it is over here on this triangle. Everybody see that? These two sides were the same, weren't they? How did you know that? How did you know that AB and CB were equal? Because they gave it to you, right? How did you know that AD and CD were equal to each other? Because this said it was the midpoint, that's right. Okay, so that means those two segments are equal, correct? Now, what about this right here? What about DB and DB? They're shared by both of them. You don't have to write this down, but if you're going to do a full-out proof, you have to give a reason for all this. And they call this the reflexive property. I just want to at least mention it to you. You don't have to write that down, but it's called the reflexive property. The reflexive property, you might have learned that in Algebra 1. Do you remember learning like commutative property, associative property, and all that kind of stuff? Well, there's also reflexive property, which said like A equals A. Do you remember seeing that in Algebra 1? Well, that comes into play right here because DB equals what? No, it doesn't equal DC. DB equals DB, that's right. It equals itself, doesn't it? DB on this triangle is exactly the same as DB on this triangle. And so what would your reason be? It would be reflexive property, all right? You don't have to write the reflexive property down, okay? I'm not asking you to give me reasons. All I'm doing is asking for those right there. I should have shaded this in a different color because it's kind of blending in. Okay. Well, just let me just finish and I'll tell you. So what do we have? I've marked these two sides, I've marked these two sides, and I've marked these two sides. Do you see how I showed these two equal to each other? Since they're not two like completely different sides, I can't put 3 and 3. So I just put 3 on this one. This means 3 tick marks on DB and 3 tick marks on DB, right? Does that make sense? So what do I have now? I've got a side equal to a side. That's one side. I've got a second side equal to each other. And I have what? A third side equal to each other. So these triangles now are congruent by what reason? Side, side, side. All right? So look, these are the things that I want you, and I'll circle these in yellow. All right? I want you to show this and this. That's part of your answer. This is a second part of your answer. This is a third part of your answer. And this is a fourth part of your answer. Okay? So this is what I want when you, if I give this to you on a quiz or a test or something, this is what I want. I want you to mark the stuff that's given, right? They tell you a bunch of stuff. They say this is the midpoint, but we had to figure something out that this is the midpoint. If this was the midpoint, then these two segments right there are going to be equal to each other. These two are equal because they're given. These two, right? It looks like one, but it's DB on one, DB on the other. They're equal to each other because it's reflexive. They're the same exact side, right? And there you go. I've got a side, and I have a side. That's it. It's not so hard, is it? It's pretty easy stuff. You didn't have to do any real math, any arithmetic, or anything like that. You just had to understand what was given and why the triangles are congruent. I think that's pretty easy, don't you? Yeah, I do. Let's do another one, okay? Let's flip it over and look at number 3 on page 50. And we'll draw this one out as well. So now we're doing page 50. That's still the worksheet. And we're going to do number 3 on this page 50. So let me draw this thing out. It's one big triangle, right? And it looks like it goes to about right here, about right there, and you go one right in between. All right, and let's label it. That's R, V, and T, and S. Now they've already marked a couple things for us, but on a quiz or a test, I probably won't mark the picture at all. You're going to have to mark it yourself. So you're given that RS is equal to TS, and you're also given, this is kind of the same. This is real close to the same, all right? But it's good to do it one more time. So V is the midpoint. V is the midpoint. I'll just shorten midpoint again of RT. This is almost identical to what we just finished doing. And we are trying to prove that the triangles are congruent to each other. That triangle RSV, oh, what am I doing? Let me put this here first. RSV is congruent to triangle TSV. Alright. And we'll do this in yellow this time. Alright, so that's what we have right there. Now, if I gave this to you out of the book, which I'm going to tonight, okay, I'm giving you problems to do from the book tonight, alright, what I want you to do is I want you to do all this. See, everything that I've written down, this is what I want you to write down to get this problem correct. So I want you to draw the picture, label all the points. I want you to write out what's given. I want you to write what you want to prove. Everybody see that? Everything that I've written right here is what you need to write if I assign this from the book. Now, if it's a worksheet, the picture's already there right on the worksheet. This is already there for you. So a worksheet, you don't have to recopy it. Excuse me. But if it's from the book, I want you to recopy it on here. Now, again, a quiz will already be on there. A test, though, on the other hand, you'll have to recopy it again. All right? So it's not that long. It'll only take you a minute to do that. Now, let's go ahead and work on this. Actually, let me give you a couple minutes. See if you can do this. All right? We basically did the same exact problem just a few minutes ago. So I'll give you a couple minutes. Take a look at it. Mark all this stuff. Show me why they're congruent to each other. And there you go. I'll give you about a minute to do this. All right, let's take a look. Shouldn't be that hard at all. It's almost identical to what we just did. I forgot the little bar at the top of this. RS is equal to TS. So what do? Tick mark. RS and TS, tick mark here. V is the midpoint of RT. Well, V right there, that's a point. That's a midpoint of this thing, this whole thing right here. So what do we put here? Two of them, right? And then, are they congruent right now with the stuff that's given? No, not yet. What do we have to show? That VS and VS are the same. So how do we do that? Put 3. See, it's exactly like it was on the other problem. So now, why are these triangles congruent? Side, side, side. And that's it. That's all. Everything in yellow there is your answer. Okay? Side, angle, side. What do you think the A stands for? Come on. Take a wild guess. I know, but listen, I'm asking you to think for a second, okay? It's the letter A. Jada, come on, don't get upset with me. Just listen to me. I'm trying to help you out. Listen to me. Just think what the A could possibly stand for. If S is for side, what's the other part of a triangle? An angle, right? I know. I am trying to get you to think first before asking the question. I understand that. All I'm trying to get you to think is this, that if S stands for side, then what do you think A stands for? If you thought about it just for a minute or so, okay, the A has to be the angle. Okay? That's all I'm trying to do. Part of being a teacher is not answering every single question that somebody asks. Sometimes part of being a teacher is getting you to think about the question that you just asked. That's why I did that, okay? I wasn't trying to be mean. I wasn't trying to be rude. All right, this is a little bit different, okay? It needs to stop, okay? I'll write you up in a half a second. I gave you some time to actually grow up for a second, but apparently it didn't happen. I had to say something. He knows what I'm talking about. Here we go. Here's two triangles right here. And it says determine which postulate can be used to prove that the triangles are congruent. It says if it's not possible to prove they're congruent, then you write it's not possible. So this is all they tell you right here. This is kind of like they're given. They've marked it right here. Is there anything else that I could say about this? What about like that reflexive property? Is there anything that's the same on both of the triangles? It's shared by both of the triangles? No, there's not. There is another thing, though. What do you say, Summer? We don't necessarily know that's a midpoint, though, do we? I mean, it might look like it is, okay, but we don't know it is because they didn't tell us it was a midpoint, so we can't say that. But there is one thing on here that we can say that's equal. One thing is equal to another thing. The vertical angles. Very good. Everybody see that? Okay, so I can't say anything about the other sides because I don't know this side is equal to this side. I don't know this side is equal to this side, so I can't do that. But I can say that this angle right here is equal to this angle right here because they're vertical angles. Do we have enough information right now to prove the triangle's congruent? Remember, we only have two ways to prove the triangle's congruent. Okay, we have side, 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 and we have side, angle, side. Can we use either one of these right now? No, we can't use side, side, side because I don't know that this side is equal to this or equal to this. I don't know that. They haven't given us enough information, have they? What about side, angle, side? Well, I do have a side and I have an angle, but I don't know one of my other sides, do I? All right, so I can't use either one of these. So can I say that these triangles are congruent? No, you can't. So what do they say to write down? Not possible. So that's what you would write. You would say not possible. And that's all they want you to do for this. Let's take a look at the next one, and let's see if we can prove that triangle congruent. All right, here's the picture on this one. Let's take a look at this. Remember, you only have two possible answers. Well, actually, you have three. You have either they are congruent because of side, 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 angle, side, or they're just not congruent at all, right? Or you can't tell they're congruent. So let's take a look. I've got one side equal to this side, so that's one set of sides, right? I've got this side equal to this side, that's another set of sides. What else do they tell you? They tell you this is a right angle. So if this is a right angle, tell me something about this right here. That has to be a right angle. Let me ask you this. So can I say side, angle, side on this?
Yes.
Yes. Yes.
Where is that angle on side, angle, side?
Right angle.
No, forget this picture. Forget this picture. Just look at this. It's what? I've said that it's in between. It's in between. Or we could say it's the what? No, it's not a midpoint. It's an angle. It can't be a midpoint. Watch. It's an included. Look, it's an included angle. We mentioned that on Friday, okay? It's the included angle. It's the one that's between the two sides. Is this angle right here the one that's between the two sides that are given? It's not, is it? Okay? So right now, just with the information that I've shown you right here, we can't say side, angle, side. All right? But there is something else that we could say, and we've done this twice already today. What is that? Because the one in between, right? Look at this side right here. We haven't labeled it, but this side is the same on this triangle as it is here. So right now you could say what? Side, side, side. You could actually say both of them. Okay, before I said you couldn't use side, angle, side because we haven't shown that side equal, right? If it was just this one, and this angle, you could not say side, angle, side. But now that we've put this side in here, you could say side, side, side because I got all three sides equaling all three sides. And you can also say what else now? Why can we say side, angle, side now and we couldn't say it before, Sean? Now the angle is between these two lines, isn't it? You see it? It wasn't between these two right here that was originally given to us. Okay, but if I do this, if I mark this side right here, I could say either side, 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 or I could also say side, angle, side. All right? Well, it's or. You could use one or the other. Okay, it's either this one or this one. That's what or means. You could use this one or you could use this one. It doesn't matter. But the thing is, you'd have to show that this side was equal. So I could say side, 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 or I could say side, angle, side. But when if I didn't have this side marked right here, I could not have said side, angle, side, could I? I have to have that third side right there marked in order to be able to say either one of those, either side, 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 or side, angle, side. So that was a little tricky. So you can pick either one of those. It doesn't make any difference on that one. All right, let's do one more. Then I'll give you some time to work on some from the book. Let's draw this one out. All right, here's your new picture. Now, they did give you a couple things. They said that this side was equal to this side. And that this one right here was equal to this one right here. That's all they tell you. What do you think? Side, side, side. That's right. Where's the third one? That's right. The one that's shared by both the triangles, right? That's all there is to it. Should be getting used to this side, side, side thing, right? And you should be getting used to that reflexive thing too, right? Okay, because this side is the same here as it is here. All right, so there you go. So these are congruent to each other because side, 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 and that's all you do for those. Pretty simple. Let's do number 7. I didn't really assign 7, but let's look at it anyway. All right, here's the picture for number 7. I know I didn't assign it, but you can do it anyway, okay? It's not that hard. Now that you know what's going on, it's pretty easy. Look, this side is given. Now, you didn't know this side was equal, but they gave it to you, all right? That's the only way that you know that they're equal to each other. And this is all they tell you right there. That's the only thing they tell you. Can you say side, side, side on this one? No, because you don't know that this side is equal to this side. Daniel, tell me. That's right. Look at these two angles right here. These two angles are vertical angles, right? And what do we know about vertical angles? They're equal. So this angle is equal to this one. So now, it's not CPCTC, okay? You only have, listen to me, you only have 2 ways to prove triangles congruent so far. Tomorrow you'll have 2 more. Okay, but today you only have 2 ways to prove triangles congruent. Side, 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 or side, angle, side. Okay, it's not CPCTC. That's completely different, all right? And I've heard that several times today, but you don't use that as a reason to prove triangles congruent to each other. So we knew that you had to put that in there yourself. You could just look at it and see that these 2 lines intersect each other. The vertical angles are equal. So look what I have. I got a side, angle, side. I'm going to have the same exact side, angle, side over here on this other triangle. So these 2 triangles now are congruent to each other because of side, angle, side. Now, let's talk about CPCTC since it was brought up. Now that you know that these triangles are congruent to each other, what do you think I could probably say? Now look, I'm going to have to take this triangle right here and kind of flip it, or twist it, or actually flip it, wouldn't I? Yeah. In order for that to match up with that and that to match up with that. So really, this angle right here is going to equal which angle down here? This one here? This one right here, that's right. Because if I flipped it around, they would match up, wouldn't they? So if I took this and I flipped it around, or not just twisted it, but flipped it, then they would match up with each other, okay? So you've already determined that the triangles are congruent because of side, angle, side. Why is this angle equal to this angle now? We already know the triangles are congruent. How can I say that this angle is equal to this? Because we already know the triangles are congruent, right? These 2 angles match up, or their corresponding angles, right? Or their corresponding parts. Good. So give me a reason why this angle and this angle are equal to each other. No, listen, I'm giving you huge hints here. I said that they're corresponding parts. I said they're congruent triangles. Now is when you use the CPCTC because they're corresponding. Look what it stands for. It's corresponding parts. Do they correspond to each other? Yes, they are. Okay, because they would match up with each other, wouldn't they? All right, they're corresponding parts of what? Congruent, not just any triangles, but congruent triangles. And what's true about corresponding parts of congruent triangles? They must be what? They must be congruent to each other. They must be equal. All right. So this angle equals this angle because CPCTC. What else could be equal here? Now remember, I've already proven the triangles congruent to each other. So I've already said that if I sit one on top of the other, they're going to match up. So if these 2 are equal to each other, what else do you think is equal? Okay, well, the other 2 angles, right? So they're congruent. Why are they congruent to each other? CPCTC, right? Because again, what does it stand for? They're corresponding parts, because they would match up, wouldn't they? If I took that and I flipped it and I put them on top of each other, they would be corresponding parts of congruent triangles. I've already proved they're congruent triangles, and they must be what? Congruent. What else is missing? The line on the top and the bottom, right? Those two third sides. So now I could say that this side is equal to this side because of what reason? CPCTC. Because they are corresponding parts of congruent triangles, that makes them what? Congruent. Okay, understand what it means. Okay, I've said it several times now. They're corresponding parts because if I took this and I flipped it, this side... I don't know why you laugh every time. If you're talking while I'm trying to explain it, you're not going to hear my explanation. That's why I want you to be quiet, so that you listen to what I'm trying to explain here. If I took this and I flipped it around and put it on top of this, this would match up with this right here, wouldn't it? That means they're what? What's the first C stand for? No, they're corresponding. Okay, that means they're corresponding. They're corresponding parts. So the corresponding parts of, what did I say is true about the two triangles? They're congruent. Okay, so if I have corresponding parts and I have a congruent triangle, what must be true about those corresponding parts? They have to be what? Congruent. Does this make sense? So really, I didn't know. There's three things that I didn't know at the beginning. Would you agree? That this angle and this angle, this one, and this side, I didn't know that at all. Actually, I didn't know this until I first looked at it, and then I said, hey, these are congruent because they're vertical angles. Now I've got congruent triangles. So now if they're congruent triangles, what about those other angles and sides that I didn't know anything about to begin with? Now I know that they're congruent to each other. Why? Because they're corresponding parts of these congruent triangles. Does that make sense? I mean, we could have gone back up here and done this as well. All right, look at this. These two triangles are congruent, right? So what must be true about this angle? Now look, this angle is opposite the one tick mark. So which one corresponds to it over here? The one opposite the one tick mark over here. Everybody see that? You kidding me? I sure hope I don't find that. So watch. This angle has got to be equal to this angle. Why would this angle right here be equal to this angle right here? That's right, because they're corresponding parts, aren't they? Because we've already established they're congruent triangles. What else would be equal? What about this one right here?
That one down.
I'll put 3 here because it's opposite the one with 3, right? Which one is equal to the one over here? Opposite the 3 here. Do you see it? See how it's opposite the 3? This is opposite the 3. So they're equal to each other. Why are they equal to each other? Because they are corresponding parts of congruent triangles, which means CPCTC. What else is equal?
That angle and that.
Yeah, this one because it's opposite the 2, right? And this one's opposite the 2, so they have to be equal to each other. Make sense? We didn't know that at the beginning, did we? But we did figure out that the triangles are congruent. So if the triangles are congruent, then all the corresponding parts have to match up. Make sense? We could do this up here if we wanted to. Look at this. Now, we know all this stuff is true because of the given that they told you, but now, watch what we can figure out. What about this angle right here? What's equal to this angle? This is opposite the side with 2. It's got to be equal to this, right? Why are they equal to each other? CPCTC. Because, again, they're corresponding parts. They're angles that match up to congruent triangles. You see it? So I've got to have congruent triangles first, and then you can say, okay, the angles that match up, the sides that match up, they have to equal each other. What else could you say was equal? This one right here, right? This is opposite the side with 3. This is opposite the side with 3. So they've got to be equal to each other. So you could say that they're equal to each other now. Make sense? So now you know all the corresponding angles are equal. Now you know all the corresponding sides are equal. But we didn't have to know all 6 of those things to begin with, did we? We only had to know 3 of them. We had to know side, side, and side. Or you could have gone side, angle, side. All right? Then all the other stuff must be equal. Let's do it one more time. Now we don't know these are congruent, do we? So can I say like that this angle is equal to this one? No, because I don't know they're congruent to each other. So you can't say anything else about the sides and angles on that one. What about this one right here? What else can you say? The triangles are congruent. This is like we did before, right? So those two angles are equal because they're both opposite to 2. These two angles are equal because they're both opposite to 3. And then these two angles right here, we don't, yeah, I guess we, I don't even want to say that they're right angles just yet. But we could say that these angles are equal too. All right? And why? Why is all that true? Because of CPCTC. Now look at this one. Look at this. Why is this angle right here equal to this angle right here? Because look, this is opposite the side with 3. This is opposite the side with 3. So these two angles have to be equal. What's my reason? CPCTC. All right. What else is equal? These two have to equal these two. Same reason. And these two have to equal these two right here. Now, they would be right angles, wouldn't they? Because if they're exactly the same and they're right next to each other, they both have to be 90, right? Because 90 and 90 is 180. So they would have to be right angles right there. And what's the reason? CPCTC. Does that make any more sense on the CPCTC thing? All right. Hopefully that makes a little more sense. So what I'm going to give you today, let's drop all the way down to here again. This is from the book, and this is for homework. Okay? Yeah, I'm going to collect that worksheet that we just went over. Okay, so here's what you're doing today. Let me find it. And I don't know, did I assign this at all Friday? I didn't. Okay, so I'm assigning it today. 267, 268. Here's what you're doing. You should be writing this down. 5 and 6, 12, 13, 14, and 15. All right, so that's your homework.
No, bro.
This is section 4.4. That's your homework right there. Pages 267, 268. You're doing these right here. Now, it's from the book, so what are you doing with the pictures here? You're writing the, yeah, you're drawing the pictures, you're writing the given, you're writing what you're trying to prove. Okay, that's your homework right there.
Are you going this way, Mr. Hammer?
What's that? I'll go that one.
This way.
The thing's still going.